Good evening, everybody. This is a live severe weather update as we have supercells that have erupted across western Oklahoma. I'm especially watching this storm just to the east of Clinton and to the north of Weatherford. Kind of a cluster of a couple of different mesocyclones here. Pretty sheared out from southwest to northeast. But I just saw some pictures from some storm chaser friends of mine, Jeremy Carter, Chance Cold Iron. They're on this storm, and it's got a pretty big updraft base right now, but still none of these mesocyclones within this line have become dominant. So this one's kind of a conglomeration of a couple different areas of rotation. Was watching that area just to the south of Clinton, right on the tail end, is actually the strongest area of rotation. That'd be down here just to the southwest of Indianapolis, to the east of Clinton, to the west of Weatherford. All of these areas of rotation are going to lift just to the north of the Weatherford area. There's a couple other little nodules as well. So this is basically a few supercell storms that are connected together in this southwest to northeast oriented convective line. And right now, I think this southern one should take over eventually. This mesocyclone will probably get a little bit impeded or seeded from these updrafts. Probably some rain, maybe some hail falling into that updraft that could help to impede the inflow a bit. But one of these areas is going to dominate. Right now, I am looking at Vance radar. So let's find a radar site just a little bit closer to this storm. We're scanning pretty high up in that storm right now, but it does have a mesocyclone at least high up in the storm, and let's see how well this is going down to the surface. We'll just go with the Oklahoma City radar. The storm right now is kind of equidistant for all these different radar sites, but if you pick a different radar site, sometimes you can get a little bit of a different angle into that storm. But I'm really watching these renegades out ahead of the convective line. That's this cluster right here. These ones have failed to dominate as a nocturnal inversion or a capping inversion has come in from the southwest and is really starting to squeeze out these updrafts further south. It does look like this is going to be the tail end Charlie action right there. And this is the one you can see those two different mesocyclones here between Clinton and Weatherford and due north of Weatherford as well. Let's see what that area of rotation looks like on Oklahoma City radar. And on Oklahoma City, this mesocyclone is dominating. Vance radar looks like maybe the southern end mesocyclone was taken over. And oftentimes these supercells will form in pairs like this, and then one of them will dominate and completely take over. Sometimes the southern one, they have unimpeded low-level flow, low-level inflow in there. Sometimes if the wind's back, this mesocyclone will take over, and then the RFD will act to choke off the one immediately to its south. On the other hand, if this tail end Charlie mesocyclone takes over, that will lead to more hydrometeors downstream that could fall on this mesocyclone and cause it to weaken. But right now, it looks like this middle mesocyclone, at least if you look at the Oklahoma City radar, is certainly starting to dominate. And we can look at a radar and loop them, and you can actually see that happen. Look at the southern one dominating. That one's starting to shrink as this mesocyclone to the northwest of Weatherford is starting to dominate. And I've been telling all my friends that if any of these supercells can survive to the northeast of Weatherford, between Weatherford and El Reno, then there is an outside chance of a tornado threat. And you can even see this embedded supercell structure right here. This is the inflow notch right there. A little bit of a wet RFD on the south side. Some dry air maybe trying to come in on the backside here. Could be the early stages of a rear flank downdraft. But right now, just basically some transient supercell structures. But these are definitely the most organized storms that we've seen so far between Weatherford and Thomas. As you can see, no tornado warnings yet. Some large hail reports. We have had some hail up to golf ball size in Miami, Texas, and the northeastern Texas panhandle when those storms first went up. But no tornado warnings just yet. The National Weather Service issued a blue box, a severe thunderstorm watch, which I think is definitely the right call on a setup like this. Just too many failure scenarios for tornadoes, and that main low-level jet axis is just a little bit off to the east of these storms. Still, though, there is a narrow window that we're approaching in the next hour to 2 hours, 23Z to about 1Z. That's about 5 p.m. Central Standard Time, all the way until just after sunset, 7 to 8 p.m. These are going to evolve, and eventually this convective line is going to reach I-35 with potentially damaging winds. We've got another severe thunderstorm warning off to the north of it between Putnam and Tologa up towards Sealing. This is a convective line producing some pretty large hail. Hail to the size of 1 inch in diameter, wind gusts to 60 miles an hour. And these storms off to the north, though, these are mainly hailers, damaging straight line winds. Winoka, you've got a big time hail core just to your north, probably some gusty winds as well. Maybe the hail covering the ground there to 1 inch in diameter. And even that severe thunderstorm warning to the west of Medicine Lodge, still in southwestern Kansas, is happening. There's a lot of lift, a lift for this upper level system, this ski jump punching in to the southern plains. This 850 low, though, was oriented from the southwest to northeast and is just now starting to close off. It was forecast to do that at about 0Z, 23Z to 0Z. That's when I anticipated that to happen. But we are monitoring these clusters of storms, and there are some renegades down here just to the north of Weatherford that I'm keeping a close eye on. There you can see a little more well-defined of an inflow notch. We kind of have these S-shaped supercells, and one thing that appears to be happening is the veer profiles that were in the mid and upper levels of the troposphere above the hook-shaped photograph seem to be dominating, or at least comparable to the low-level shear. But if these can make it to the northeast of Weatherford, between Weatherford and El Reno, that's when the wind shear really ramps up, when they get to the western edge of that low-level jet. And then there's a chance that the cyclonic part of that photograph could dominate the veer profiles here. But definitely a well-defined inflow notch. This is one of the mesocyclones. There was one also at the tail end of this convective line that's probably getting some impeded inflow a bit. Also got a tail end Charlie down here to the west of Clinton. Nice hailer that looks like it's struggling just a bit. So really this mesocyclone due north of Weatherford. And look at this gradient in the forward flank here. This gradient in reflectivity is definitely tightening and getting more of a concave look. So that means that we're probably getting a mesocyclone that's starting to dominate here between Weatherford and Thomas, lifting off to the northeast. Definitely could develop a tornado threat, especially as it gets a little bit closer to the Watonga area. And these last few radar scans, it definitely is starting to get more of a concave type of a pattern. Just got a text message, though, from a storm chaser friend I know that's underneath it, and they said it's done. So they don't think that it looks very favorable for tornadoes right now. This storm, these last couple radar scans definitely do look a little bit better on reflectivity. Velocity, though, looks like the mesocyclone is starting to lose a little bit of its strength. But usually when you get this very large concave area, it could be a storm that's trying to consolidate its inflow around a dominant mesocyclone here. But it's also possible that some of these renegades, these other updrafts off to the southeast, have just rained a little bit too much on a marginal thermodynamic environment, and these are definitely impeding the inflow into these storms as well. But this is the one I'm tracking between Thomas and Weatherford, Oklahoma, lifting off to the northeast toward the Watonga area, breaking down the radar on the Radar Omega app here. This severe convective line marching from west to east across western Oklahoma, and one renegade with an outside threat of producing a tornado down the line as it's lifting off to the north of I-40, to the north of Weatherford. Let's take a look at a surface map here as well. Maybe we could start to break down this a bit more. We'll also look at the RAP analysis here and kind of see how the thermodynamics are holding up. Pulling up this site right now. Thank you for joining me for my weather reports here. We do radar breakdowns, mostly storm chasing, but when we're not storm chasing, we still do these live radar breakdowns. And here is the surface map. This is the latest, and a lot of stable air, a lot of fog around the Oklahoma City metro. Temperatures in the mid-50s. No way severe weather is going to make it into the Oklahoma City metro unless a big elevated convective line comes in with some isolated severe winds, maybe some hail. Here is this instability axis. It did make it into northwest Oklahoma. Temperatures in the low 60s up there, dew points around 59, cloudy skies. It did, however, notch into southwestern Oklahoma all the way up to the I-40 corridor with temperatures lifting up into the 70s, even an 80 down there in Frederick behind the dry line at 80 over 41. And the dry line has marched into the first couple of counties in western Oklahoma. Cold front coming into the northeastern Texas panhandle with temperatures dropping into the 40s, eventually the 30s in southwestern Kansas, where winter weather alerts are in effect. Winds at Gage now gusting 25 miles an hour out of the northwest with temperatures dropping into the 40s. And Gage had a wind gust reported at 64 miles an hour inside a severe thunderstorm warning there. But really, this storm that is just now lifting to the north of I-40 is the only one that has a chance to produce a tornado. But based on the surface map, it definitely looks like relatively limited instability available for these storms. Let's look at the mesonet. We're in Oklahoma. Definitely makes sense to use the mesonet here. Oops. Here's the air temperature. And look at that area of 70s right there bleeding into southwestern Oklahoma. And that says that elevated mix layer was coming over top of this moisture, and the dry line was marching to the east. Storms developed on the northwest side of this instability axis. And if those supercells can survive with strong mesocyclones into this environment, this is where all of the strongest wind shear is located. But look at the temperatures up there. They're right around 60, low 60s, quite stable to the north of this axis. Slide this mesonet image just a little bit off to the left. So the strongest wind shear is actually co-located with temperatures around 60 up here. And so you did have the elevated mix layer come into southwestern Oklahoma. You've got that cold front right now that's coming in to the northwestern Oklahoma. Yes, I'm getting text messages from storm chasers saying elongated updrafts. The mesonet.org is a pretty incredible site to look at these awesome changes in the relative humidity. Look at that relative humidity dropped with that dry line surging into southwestern Oklahoma, punching those temperatures into the 70s there. Have an increase in relative humidity over central Oklahoma. Today's maximum minimum temperatures. Damn. Getting phone calls coming in here. So here are the dew points in the Oklahoma mesonet. You can see the dry line that punched into the southwest part of the state. Dew points dropping into the upper 30s and lower 40s. Dew points did get into the low 60s across southwestern Oklahoma to the east of that dry line. Here's the cold front with those dew points dropping into the 40s, with temperatures dropping into the 40s also. Here in northwestern Oklahoma, with that further south track of the triple point right along the I-40 corridor, dew points basically stayed in the upper 50s. Up there, but I'm definitely getting reports in the field that people are saying that these storms just are not happening down there. And it really means that the capping inversion is starting to build in. If you look at the latest RAP analysis, all of that blue is convective inhibition or capping, and right now there's just a little bit of a hole in that capping inversion right where that severe thunderstorm is located. But all the strong wind shear is on the eastern gradient of this instability axis. And that's out here. There you can see where the strongest wind shear is. These are effective helicities, storm relative helicities, basically the low-level helicity, the lowest kilometer or two. And really the strongest wind shear, the western edge of that low-level jet, is over pretty marginal thermodynamics. And you can see that the dry line punching into southwestern Oklahoma, of course, you have a dramatic reduction in the wind shear there. But really, it looks like the convective inhibition is starting to build in rapidly around these storms. So the window to produce tornadoes certainly closing. Let me square this thing up a little bit. This is the latest RAP analysis. And really the timing of the system wasn't quite appropriate. The shape of the upper level system, especially that 850 low, was a little bit stretched out from southwest to northeast, and that caused the low level jet to get pushed all the way east into eastern Oklahoma, southeastern Kansas. And that left behind a pretty weak low-level environment in the lowest kilometer or so for these storms that were right along that 850 trough axis, but they still are severe. Big hail cores in here, big straight-line winds. An attempt at a half-ass renegade there just to the south of Alva, about to get absorbed by the line. Little renegade here that has no chance, but definitely about to get blasted by this convective line surging in from the west, about to get absorbed. Severe thunderstorm warning. Winds up to 70 miles an hour in this convective line. That's going to head toward areas like Alva, eventually Cherokee, Burlington, Tacoma, Carmen. East of Winoka now. But definitely we're transitioning to more of a straight line wind threat with this broken convective line well to the west of the low-level jet, and that's why we haven't seen a single tornado warning yet. Still, though, this one north of Weatherford is trying to hang on, but you can kind of see it's moving north of that instability axis. Basically, the updrafts are trying to hang on here on the southern side. Those updrafts that lift to the northeast are dying with the capping inversion. So this is probably the only surface-based updraft that's left over in Oklahoma right now, and it is not rotating. Still to the west of that wind shear, and I think that by the time it gets to that wind shear, it's going to go elevated and lose its thermodynamics. So I think that the tornado threat is starting to converge to zero here in western Oklahoma. Oops, let me put on the radar. There's the radar to the north of Weatherford, and as I was just telling you, these dominant updrafts are staying on the tail end side of this convective complex, and these ones that lift to the northeast just die out. They move, just get choked off by convective inhibition. This one's probably going to meet the same fate. Really minimal rotation here, even at the tail end, almost none. So it looks like these storms are going to go elevated well before they reach the stronger wind shear, which is out in this area between Weatherford and Hennessy. Kind of out in this zone is where the strongest wind shear is located. But the thermodynamics become much less favorable as this storm will move into that environment. So I just don't think that the tornado threat is going to materialize, which is good news for the people of northwestern Oklahoma. But severe weather is going to happen. Winds gusting to 70 miles an hour. Large hail out here. Winoka, Alva area. Half-ass attempt at a renegade right here. A little S-shaped, stretched out convection. So really what happened is the low-level jet was pushed into eastern Oklahoma. It hasn't had a chance to fire up yet. It's 4:20 right now in Oklahoma Central Standard Time. And really in about an hour to 2 hours is when that low-level jet is really going to ramp up. And I'm just not sure that these storms can hang on until then. We'll just have to see. Let me take a look at some of these messages. Elongated updrafts in warm sector, rough chase. It's done. So everybody's saying that it's basically done right now. And these are storm chasers, well-trained storm chasers with eyes on the ground underneath the storm. Some of the best forecasters I know, some of the best at observing storms. And they're saying that these probably aren't materializing. This severe thunderstorm warning now has winds less than 50 miles an hour, all for hail to maybe 1 inch in diameter. And this southern updraft is probably in the process of dumping its hail core. So what happens is the storm will support a hail core high up in the atmosphere, and once that updraft starts to weaken, boom, the hail core comes down all at once. That's called a hail core dump. It's usually a sign that the storm is about to die out. Eventually, these are all going to merge into a big convective line that's going to march all the way to Interstate 35. Really quick, we can pull up the HRRR and see what this convective line, the timing of this convective line. I'm on the Radar Omega app right now, breaking down this severe weather. And there could be a snowstorm in early December down here in the Carolinas, where I'm located. So I think this surface low came out a little bit weaker and further south, closer to western Oklahoma than the earlier models were showing. So let's go and look at the HRRR here as of 2Z, showing that surface low. Still, the HRRR has a surface low too far north. So there's definitely still a discrepancy between those two, between the RAP and the HRRR. But I'm more using this just to get a timing. A lot of times the HRRR will be right for the wrong reasons. And this is at 5 p.m. and this really doesn't look much like what's happening right now. So the HRRR is already inaccurate. But it kind of has these renegades getting strung out as they lift into that unfavorable thermodynamics. So really the HRRR is not showing much severe weather making it to the I-35 corridor, but these thunder showers are going to make it to I-35 by about 1Z, 7 to 8 p.m. This convective line will be arriving at I-35, and you'll probably have a couple of severe thunderstorm warnings, but it definitely is a weakening convective line as the convective inhibition ramps up. But then we've got to watch these renegades that could develop from the Arklatex through the Ozarks by about 9 p.m. And that mode could maybe have an outside threat of a tornado down there. It's near the core of the low-level jet. By about 3Z, 9 p.m., you can see this convective line building into eastern Oklahoma. Let's see where the low-level jet's located by that time. And it is possible that in eastern Oklahoma, there could be a couple tornado warnings embedded within that convective line when it finally meets up with a low-level jet. And then some of these renegades, if they can get going in this 50 to 60 knot low-level jet core, they'll have a chance to develop tornadoes, but the thermodynamics are really lacking down there. Not any cape from the Architects all the way through the Ozarks. Zero cape, surface-based instability. You really need those mid to upper 60s dew points advecting way to the east with a big low-level jet and a big open wave. And really, you've got dew points in the low 60s to even 50s across the Ozarks. So it seems to me like this setup's going to be a bit of a nothing burger. Oh, dang it. I keep forgetting to show you guys. So I'll run through this model again because of my error here. Let's go back to the beginning. So this is initialized quite accurately with this moisture axis wrapping around the dry line punching into central Oklahoma. For some reason, though, the HRRR analyzes the surface low here in northwestern Oklahoma, but really the triple point is closer to I-40. Here you can see that convective line. Those severe thunderstorms off to the north. It did pick up on those renegades developing in southwestern Oklahoma, but the convective line is a bit closer to slamming into them. And it does show these renegades being a bit elevated as they lift into central Oklahoma, closing in on the central Oklahoma corridor. Still these couple elevated supercells and severe wind gusts possible with this line. But really it's weakening and losing steam as it gets closer to the I-35 corridor by about 2Z, which would be like 7, 8, 9 o'clock here. Maybe some severe thunderstorm warnings in this. It's going to arrive in Wichita by about this time. 8, 9 o'clock. And it seems like you have a couple of bands of convection that develop, probably with sub-severe, marginally severe weather. But eventually when this convective line reconsolidates by about 9 or 10 p.m. in eastern Oklahoma, it'll at least be into some more favorable wind shear. 3Z is about 9 p.m. Central Standard Time. And it looks like we could have a reinvigoration of that convective line here in eastern Oklahoma. Tulsa down toward Muskogee. Down toward McAllister. Definitely could get some borderline severe weather as this convective line, maybe with some embedded supercells, moved into eastern Oklahoma later on this evening. And there's still a 50-knot low-level jet here in far eastern Oklahoma too. So let's take a look at a forecast sounding. And that's it. Look at this giant looped hodograph right here. There you go. Here's that veer back veer pattern I was telling you about that's kind of given most of the updrafts a strung outlook, and that's because they were west of the low-level jet axis where you had just a little hook-shaped hodograph on the southwest of it and then big veer back veer. But if this convective line can make it to eastern Oklahoma with any robustness, this is obviously a big shear vector of about 50 knots. Very poor thermodynamics though, 57 over 56, big stout cap. Huge stable layer, so that's going to minimize even the chance of QLCS tornadoes in eastern Oklahoma. So overall, this looks like it's going to be more of a nothing burger, but still a good chase. Always good to chase and see that elevated mixed layer go overhead. The skies go blue. Southerly winds at your back. The moisture surges. But it didn't pan out, not because of the lack of breaks in the clouds. There was plenty of instability for these. It was just a lack of timing, a misshapen 850 trough, not really consolidating and becoming bulbous until too late, until after the threat of surface-based convection has passed. But that's what we try to do, is understand those severe weather events that go big and those that end up being a little bit less extreme. Still, though, we got to watch this tail end Charlie storm down here to the north of Weatherford, to the east of Thomas. See if there's any rotation in there to the east of Thomas. Still a little bit of an enhanced inflow. This is Vance off to the northwest. And it does look like this southern one is still trying to go. So we can't give up on that yet. Still is a chance this southern end could take and develop a tornado threat as it lifts off into the northeast into that greater wind shear, despite surface temperatures cooling and stable air kind of dominating out here. A little bit of a broad concavity to the gradient here in reflectivity on the southeast side of the storm. And here you can see the HRRR was picking up on these storms going up downstream too. Elevated storms that could develop severe potential. And these will approach I-35 first by about 7 or 8 local time. Big blob of storms are a cluster here in northwestern Oklahoma. Big squall line producing 70-mile-per-hour winds. Severe thunderstorm warning extended east. That includes Cherokee. So definitely extending transitioning to more of a straight line wind event. Definitely some big winds getting picked up in here. That's up to about 30 meters a second. Definitely getting some winds gusting up to 60 at least. The winds aren't as strong along the leading edge of that convective line. They kind of ramp up behind it. A couple of pops up here near Tacoma. But definitely some stronger winds back behind it. Probably get a bit of a wake low type of a situation. Some stronger winds up here near the Oklahoma-Kansas border to the southwest of Kiowa, to the northwest of north of Alva. Some stronger winds, maybe gusting to 60 up there, closer to the Kansas border. And some stronger winds also with this convective line, approaching 30 meters a second there as well, 33. So they're starting to gust over 60 miles an hour up there. And then some pretty weak winds with this renegade, but it is trying to hang on to a mesocyclone, but is getting elevated and strung out at the same time. So that's the synopsis here in western and northwestern Oklahoma with severe weather. Thank you guys for tuning in to my weather reports. Everybody say hi to my mom. She's in here dominating. She's been solo in her house here through the whole pandemic. But Team Dominator is now here broadcasting live this severe weather event. So thank you everybody for tuning in. And I'll go live if a tornado threat rematerializes.